Hey everybody. I'm sorry I'm not with you today. I hope this lesson goes smoothly for you. Today we're going to talk about the first of several important theorems. Now I don't want you to stress about theorems and think, oh my gosh, geometry. It's not like that. I think we talked a little bit about this theorem last year when you were in pre-cal. I'm going to have to pick on somebody. So I'll pick on Micah. Now I'm going to pretend on some numbers here, Micah, because I'm not sure. Right now, I'm going to guess, let's say you're 5 foot 11 inches tall. So don't write this down, okay? So Micah, as a senior, 5 foot 11 inches tall. Well, when he was in the 6th grade, let's say he was 5 feet 4 inches tall. Was Micah ever 5 feet 7 inches tall? Now, I know that sounds like a duh question. Was he? Of course. Height growth is a continuous function because every age that you are, every moment that you are alive, you have a certain height. So there are no heights that are skipped. So here's what we know. We know that somewhere between Micah's 6th grade year and Micah's senior year, he was 5 feet 7 inches tall. Now, we don't know exactly when that happened. We just know it had to have happened. Ladies and gentlemen, that is the intermediate value theorem. The intermediate value theorem is what's called an existence theorem. And that means we don't know exactly when, we just know it did happen. So, let's see if we can write up the intermediate value theorem a little bit more formally. But I still don't want you to write yet. I'm going to write it up more formally, but I'm still going to use Micah. Age, height. 6th grade, 12th grade. 5 foot 4, 5 feet 11. Here's what we know. We know in 6th grade, I shouldn't say age, I should put school year, shouldn't I? In the 6th grade, he was 5 foot 4. In the 12th grade, he's 5 foot 11. And the question is, was he ever 5 foot 7? Of course. We don't know how he gets from 5 foot 4 to 5 foot 11. He could have done this. He could have done this. We just know he got there. We know that height is a continuous function. So what do we know? We know that his height was a continuous function, and we know that 5 feet 7 inches is between 5 feet 4 inches and 5 feet 11 inches. Those are the things that we know. So here's how it works. And again, don't write this down. I'm going to come back formally with mathematics in a little bit. Height is a continuous function. Five feet 7 inches is between 5 feet 4 inches and 5 feet 11 inches. By the intermediate value theorem, now that's a new symbol for you. There exists an age, or no, a school year between 6th grade and 12th grade such that Micah was 5 feet 7 inches tall. That's what the intermediate value theorem says right there. Now you're like, yeah, but that's not what the AP exam is going to ask. You're right. So let's do it with just math. We have some function. I'm going to call this function f. And that function f is continuous from A to B. The first thing that has to happen for the intermediate value theorem to apply is that f must be continuous on the closed interval A, B. That's first. Now, let's see. Here's f of A. Here's f of B. Now, here's the question. Is there some number, some x value in between A and B such that f of, and we're going to call that number C. So is there a value C between the x values of A and B such that f of C is equal to L? So here's the second piece. If, I don't want to use the word if, f of A is less than L is less than f of B. Now, listen, it also could be this. It also could be f of B is less than L is less than f of A. It doesn't matter if the function is increasing or decreasing. That's irrelevant. What has to happen is this number L has to be between f of A and f of B. So if your function is continuous on the closed interval A to B, and this number L, 5 feet 7 inches, is in between f of A and f of B, in between 5 feet 4 inches and 5 feet 11 inches, then we are guaranteed, then there exists a C on the open interval A to B. Oops, I don't need a comma. Such that, and you can abbreviate such that as ST, f of C equals L. The function must be continuous on the closed interval. F of A, excuse me, L must be between f of A and f of B. And you are guaranteed, and I should have inserted one thing, then by the intermediate value theorem, and you can abbreviate IVT, there exists a C on the open interval A to B such that f of C is equal to L. Okay, I have to erase this by IVT, but you do have to write that. Whenever you are using a theorem to defend your answer, you have to write what the theorem is, but you can use abbreviations. Now, investigate the graphs below to determine if the theorem is applicable for these functions on the specified intervals given. All right, so let's look at this first f of x. Well, dang it. Here's the question right here. Is there a value of C on the closed interval 5 to 2 such that f of C is equal to 2? The first question you have to ask is this function continuous on the closed interval -5 to 2? Here to here. No, that function is discontinuous at x equal -2. Now here's the deal. There may be a an x value between -5 and 2 such that the y value is 2. In fact, it does exist. It's right there. However, the intermediate value theorem does not guarantee it. You cannot use the intermediate value theorem to justify it because the foundation of the intermediate value theorem, the criteria for the intermediate value theorem, that the function is continuous on the closed interval, is not met. So, is there a value? Yes. Does the intermediate value theorem guarantee it? Guarantee its existence? No. F is not continuous on the closed interval -5 to 2. So the intermediate value theorem does not apply. You cannot use the intermediate value theorem. Now, the author's notes go into a little more detail than that, but you do not have to. That is sufficient. Now, let's look at the second one. We're looking at this question right here. Is there a value of C on the closed interval -1 to 5? So we're on a different interval. -1 to 5, such that f of C equals 2. Is there? Nope, there's not. Why? Well, here's what we know. We know that f of -1, well, let me write it up here because I have so little room. F of -1 is what? Roughly -0.5, and f of 5 is somewhere between -3 and -4, so let's say roughly -3.5. Is this y value that we are looking for in between those two numbers? No. So if we didn't have the graph, all we had was this, we still could not say that the intermediate value theorem will apply. It might, but excuse me, let me back up. This might exist if this piece right here is all we know. But the intermediate value theorem does not guarantee it because this 2 that we need is not in between the -1/2 and -3.5. So let's look down here. Please don't get stressed out. I promise intermediate value theorem is not difficult. Look at the question here. Does the IVT guarantee a value of C such that f of C equals 2 on the interval -1 to 5? IVT, well, let me do it this way. F of -1 was about what, -0.5? F of 5 was about -3.5. Now, if you go back to our theorem up here, look at this piece right here. That number we're looking for has to be in between the two y values that were given on or at those endpoints. 2 is not between -1/2 and -3.5. So intermediate value theorem does not apply. What two conditions must be met or must be true to verify the applicability of the intermediate value theorem? Now the big one, f must be continuous on the closed interval a to b, whatever a and b are. And number 2, f of c, or that L value that we're looking for, must be between f of A and f of B. Now, I think the rest of this whole lesson is just practice. Yep. Here we go. Now, please write things correctly. Don't create new ways to write stuff. For each of the following functions, determine if the intermediate value theorem is applicable or not, and state why or why not. If it is applicable, find the value of C guaranteed to exist by the theorem. Question 1. F of x equals x minus 3 over x plus 2 on the closed interval -1 to 3. And we're wanting to find, is there an x value in between -1 and 3 such that its y value is 2/3? Now remember, the first thing you got to decide is the function continuous on the closed interval? Now you look at this function, this is a rational function because there's a variable in the denominator, and you say, oh, that function is discontinuous because it's got a vertical asymptote at x equal -2, which it does. But is -2 on this interval? No. So the only discontinuity in that function is at -2, which is not on that interval. So f is continuous on -1 to 3. Now let's find what is f of 1, what's f of -1 and what is f of 3. We need to find what the y values are of those endpoints. When x is -1, what have I got? -1 minus 3 over -1 plus 2. F of 3 is 3 minus 3 over 3 plus 2. Is the y value that we are looking for 2/3 in between the y values of the endpoints of that interval? No. Now listen, the y value of 2/3 may exist, but the intermediate value theorem cannot be used to justify it because the criteria for the intermediate value theorem are not met. So what are you going to say? You're going to say, therefore, IVT does not, well, hang on a minute. 2/3 is not between, what was it, -4 and 0? So IVT does not apply. You have to state that the intermediate value theorem does not apply and why. Now let's go to number 2. Number 2 is exactly the same function with exactly the same y value here, but on a different interval. Now we said that this function, this rational function, was discontinuous at x equal -2. Oh, but look, -2 is on that interval. F of x is not continuous on -4 to 1. So, intermediate value theorem does not apply. See how easy that one was? As soon as you knew that that function was discontinuous on that closed interval, you're done. You know that you cannot use the intermediate value theorem for justification. Number 3. P of x equals e to the x plus 2 times cosine x on the interval -2 to 1 for P of c equal 5. I'm trying to find, is there an x value between -2 and 1 that has a y value of 5? Now remember, I'm trying to use the intermediate value theorem to show that it exists. The intermediate value theorem is an existence theorem. It will not tell me what x value has a y value of 5, if any. It just will tell me if I can use the intermediate value theorem, if I am sure that there's one there. So first question, is this function continuous? Here's the deal. E to a power is an exponential function. An exponential function, remember, looks like this. Those are continuous. Cosine x looks like this. Cosine is continuous. If you multiply two continuous functions together, you get a continuous function. All you have to say here is p of x is continuous on the closed interval -2 to 1. Now we have to say, well, is this 5 between the y values of the endpoints? P of -2 is e to the 0 times the cosine of -2. Oh, you're going to have to use your calculator on these. So that's approximately -0.416. Anytime you round in calculus, you round to 3 decimal places. What's P of 1? Well, P of 1 is e to the 1 plus 2 is 3, e to the third times the cosine of 1. Remember, you're in radian mode when you're doing these on your calculator. That's approximately 10.852. Is the y value of 5 in between the y values of my endpoints? Yes. So you're going to write -0.416 is less than 5 is less than 10.852. Now another way you could have written that, you could have written P of -2 is less than 5 is less than P of 1. Either one of those, this or this, is fine. Therefore, IVT applies. So here's what we know. We know that there is guaranteed to be an x value in between -2 and 1 such that the y value of that x value is going to equal 5. Okay? We don't know what that x value is. Let's see if we know enough to find it. So you say, okay, fine. Now I'm going to erase this so I don't have to keep going down. I want the y value to equal 5. So e to the x plus 2 times cosine x, I need that to equal 5. Now listen. Well, I can put this as a c because of this c right here. Go to your calculator. That would be a c also, wouldn't it? If you put x's there, that's just going to be a spelling error, no points off. Go to your calculator, graph this in y1, graph this in y2, and find your points of intersection. Now remember, you're only looking for points of intersection on that interval. You should get c is about -0.334. That is the x value on this interval that has a y value of 5. 2 more. F of x equals x over x minus 2 on the interval -1 to 1 for f of c equals -1/2. What I'm looking for then, is there some x value between -1 and 1 that has a y value of -1/2? Does the intermediate value theorem guarantee the existence of that kind of x value? So number one, you have to decide, is this function continuous on this interval? Well, that function is continuous everywhere except at x equal 2, because at x equal 2, that denominator is 0. X equal 2 is not on this interval, so the function is continuous on that interval. F of x is continuous on that interval. Now let's find f of -1. We need to see what the y values are for the endpoints. What is that? -1 over -1 minus 2, -3, so that's a third. F of 1 is 1 over -1, which is -1. Is the y value of -1/2 between -1 and 1/3? Yep. So negative 1 is less than negative 1/2 is less than 1/3. So the intermediate value theorem applies. Now let's go find it. Remember, you don't use intermediate value theorem to find the x value. Intermediate value theorem just tells you whether or not it's guaranteed to exist. Now we're going to find it. We're going to take our function and we're going to say, does it ever equal negative 1/2? I'm going to cross multiply. Well, I'm going to cross multiply if I got the problem in front of me. 2x equals negative 1 times x minus 2. So what's that give me? 3x equal 2, x equal 2/3. Is 2/3 on the interval negative 1 to 1? Yes. So that is the x value on that interval that has a y value of negative 1/2. One more. Number 5. We're looking at a function called f of x on the interval 3 to 5, and we want to see, does the intermediate value theorem guarantee us that there is an x value between 3 and 5 that has a y value of negative 4? First thing you're going to do is you're going to say, well, is f of x continuous on the closed interval negative 3 to 5? This function is an exponential. The base is a half, which means it's exponential decay. It has a reflection over the x-axis, a reflection over the y-axis. It has a horizontal shift and a downshift. But that thing is still continuous. None of that would make there be a hole or an asymptote. F is continuous on the closed interval 3 to 5. Now let's find the y values of the endpoints. F of 3 is the opposite of 1/2 to the, what's that, to the 0, minus 2. A half to the 0 is 1. Negative 1 minus 2 is negative 3. F of 5 is the opposite of 1/2 to the negative 5 plus 3 is negative 2. A half to the negative 2 is what? 1 is 2 squared, so that's 4. Is that, whoops, a half square, come on, Stennett. That is 2 squared, which is 4. So the opposite of 4 is negative 4 minus 2 is negative 6. Is the y value that we are looking for between negative 3 and negative 6? Yep. Negative 6 is less than negative 4 is less than negative 3. Therefore, intermediate value theorem applies. Now let's see if we can find that that x value between 3 and 5. That has a y value of negative 4. Oh, come on, Stennett. All right, add 2 to both sides. Now notice I put x, I could have put c. Don't stress about it. That's a spelling error. It's not a deal. Okay, now you're thinking, what am I supposed to do with this? Let's divide both sides by this negative. So I'll have 1/2 to the negative x plus 3 equals 2. Now I know what you're thinking. Why can't I use my calculator? The answer is you can, but I want you to remember how to do this by hand. I want you to look at this. Now remember, you could write this. I promise it's not that bad. 1/2 to the negative 1 is 2. So this is 2 to the x minus 3 equals 2. Your bases are the same. Therefore, the exponents must be the same. So x minus 3 equals 1. So x equals 4. Now, wasn't that more interesting than doing it on the calculator? Yeah. The big things on intermediate value theorem is the function continuous on the closed interval, and does the y value that you are looking for fall between the y values of the two endpoints of the interval. If those two things happen, then the intermediate value theorem applies. If either one of those does not happen, then the intermediate value theorem does not apply. Now, it does not mean that, hey, maybe that y value, it doesn't mean that that y value doesn't exist. It just means that I cannot use the intermediate value theorem to prove that it does. I'll see you next time. Bye.